Good evening. My name is Sasigrada, and my student ID is W1947920. This is my coursework for Games Networking and Security Phase 2. So this video demonstrates my coursework project for the module Games Networking and Security. The project is called Photon Multiplayer Game. It is a Unity-based game, multiplayer game that demonstrates secure data handling, real-time networking, chat systems, and global leaderboards. Um, when we're looking at the authentication and user flow, when the game starts, the player is required to authenticate before accessing any online features. The game supports both anonymous guest login and email/password login using PlayFab. This ensures that backend services such as chat and leaderboards are only available to authenticated users, which you will see when I log in through the main menu. Once authenticated, the player proceeds to the main menu. Player data is persisted and locally across sessions. The stored profile includes a username, total wins, total kills, and total deaths. This data is not stored in plain text. Instead, it is serialized to JSON, manually based 64 encoded and then encrypted. When making the lobby, I'm going to use Dilshad and Ahmed, my two names of my two close friends. Encryption uses AES 256 in CBC mode with PKC S7 padding with integrity ensured using HMAC SHA 256. Keys are derived at runtime using PBKDF2 with SHA 256 and high iteration count. Also, with lobby chat, the game includes a real-time lobby chat implemented using Photon Chat. Players can communicate by just pressing T before joining a match. The chat identity is explicitly synchronized with the player's chosen username to maintain consistency. During gameplay, chat remains available. The in-game chat panel can be toggled using a keyboard hotkey, which is T, and does not interrupt player controls. This allows for communication without affecting gameplay. This is a live multiplayer match using Photon Pun. Player movement and combat are synchronized across the network at the end of the match. The authoritative client determines the winner and broadcasts the result using Photon RPCs. When we look at the global leaderboards, the project includes two global leaderboards implemented using PlayFab. The first leaderboard tracks total wins across all sessions and players. As you can see when you open global leaderboard, the second leaderboard is a custom metric based on lifetime kill/death ratio. Since PlayFab's statistics only support integers, the KD value is scaled before submission and converted back for display. When we look at ethics, privacy, and design decisions, from a privacy and ethical perspective, the game follows data minimization principles. So, no real-world personal data is stored locally. Chat messages are not persisted, and leaderboard entries display only non-sensitive metrics. Encryption and authentication are used to protect player data. In conclusion, this project demonstrates secure multiplayer networking, persistent encrypted data storage, real-time communication, and ethical data handling. It satisfies all technical professional requirements of the coursework as well. Hope you have enjoyed, and thank you for watching.